This is Jack DuPuy, Will Heinle, and Maddie Hitching at the University of Richmond, and our project involved working with the City of Richmond and other organizations to replace sidewalks with native trees to lessen the urban heat island effect that disproportionately affects underserved neighborhoods. We also use spatial analyses to identify other sidewalks in Richmond where we can implement this process.
I'm Laura Johnson. I work for the Virginia Department of Forestry, and we're here today doing the final touches, planting our trees after we previously lifted sidewalks a couple months ago. And the great part about this project and the other project we did at Hull is that it's a continuation of the work we did in 2021, where all 10 colleges in partnership with the Science Museum and the Virginia Foundation of Independent Colleges came out and assessed heat islands in 10 communities, and Richmond was one of those. And so this area was identified as a heat island and a hot spot, so we were able to, in partnership with the city and the students from University of Richmond, to lift up these sidewalks and plant these beautiful trees that are going to be here for the future, and super excited. The neighborhood is very excited, and I can't wait to see them grow.
So, as Laura Johnson mentioned, this whole project was really brought about because of some research that they did with urban heat islands in 2021, and so I want to kind of touch on what those are, why they're important, and also why removing sidewalks in favor of trees is important for mitigating those concerns. So, for one, the urban heat island effect occurs when cities experience higher temperatures, lower air quality, and increased health problems as a result of factors such as a high number of impervious surfaces, low canopy cover, minimal wind because of the tall buildings, that type of thing. These urban heat islands can cause temperatures to be up to 10 degrees Fahrenheit warmer in cities than in the surrounding areas, and this kind of temperature imbalance is projected to get worse as a result of climate change. As a further note, these urban heat islands have also been shown to disproportionately impact historically underserved communities, including racial minority groups and low-income households, right here in Richmond and also around the country. And so by doing what we're doing with the sidewalk removal in favor of trees, we're going to be reducing impervious surfaces, increasing canopy covered, and hopefully decreasing temperatures, decreasing those effects of those urban heat islands, with the goal of improving the environmental justice here in the city, fighting against climate change and the urban heat island effect in general, and just doing our part to get involved in the community, and hopefully, I mean, this is really also a pilot project for sidewalk removal to happen not only around the entire city of Richmond, but also around the entire country.
To assist the city with their objectives, we use ArcGIS Pro to generate spatial analyses and find all of the 8-foot wide residential sidewalks around the city, and overlaid that data with respect to canopy cover, temperature, and impervious surface data from around the city. Here's Will to talk more about the methods.
Our original data source included all paved surfaces in the city of Richmond, so to isolate sidewalks, we first selected surfaces directly adjacent to roads. There's no simple width tool in ArcPro, but we reasoned that measuring the distance between each shape's centerline and edge and multiplying by 2, we could calculate width. To do this, we developed a complicated model that essentially converts between shapes, lines, and points to measure this distance without interference from odd shapes or endpoints. The benefit of modeling instead of repeating steps is that we can easily change the sidewalk width threshold. We started at 12 feet, then calculated for 10 feet to comply with the Americans with Disabilities Act for accessible sidewalks, then 8 feet by request from the City of Richmond. Our output is a layer with all sidewalks in the city above our set width threshold. Quality checks revealed surfaces that fit our criteria, but were not feasible to plant trees in for various reasons, some examples being the Richmond Raceway or the Richmond Coliseum. We applied a residential zoning filter since the areas are more likely to have trees planted.
I'm Andrew Ali. I work for the City of Richmond as the Trails Manager. I also am a resident of this neighborhood, and that's sort of where this project prompt sort of came from. We as a neighborhood sort of noticed how barren and just sort of tree deficient this block was. So we teamed up with the city as well as the Department of Forestry and Chesapeake Bay Foundation, and we're able to pull funding and resources and actually make this happen. So we're sort of treating this as a pilot to hopefully remove more sections of unnecessary sidewalk and replace them with tree lawns particularly in places that are acknowledged as heat islands, because we know how heat islands can negatively affect the health and welfare of neighborhoods. So I'm really excited, and hopefully this is the first of many.
We are extremely grateful to have been able to participate in this project to lessen the urban heat island effect and improve sidewalk appearance and air quality in Westover Hills. We would like to thank the Virginia Department of Forestry, the Chesapeake Bay Foundation, the National Fish and Wildlife Foundation, the City of Richmond Parks and Recreation Department, the Richmond Workforce Development Board, and Groundwork RVA for their cooperation. We would especially like to thank Ann Yorchik, Laura Johnson, Andrew Ali, Michael G., and John Harrison for coordinating with us on this project. We look forward to the future of sidewalk tree plantings in Richmond and other cities affected by the urban heat island effect.